Alright, this is the sixth and final video for assignment number 48, which is solving systems of linear and nonlinear equations. So here we're going to look at a system of nonlinear equations. We have a line y equals negative x plus 1, and we also have a circle x squared plus y squared equals 25. That's a circle of radius 5 centered at the origin. Notice how the first equation is solved for y, so we're going to use the substitution method. So we have x squared plus, and instead of y squared, we're going to put negative x plus 1. So we're going to perform that substitution. Quantity squared is equal to 25. Now let's go ahead and work out what negative x plus 1 squared is. That means negative x plus 1 times negative x plus 1. We'll go ahead and FOIL that out. It's going to be x squared minus x plus 1, or x squared minus 2x and plus 1. So now we have x squared plus x squared minus 2x plus 1, and this is a quadratic equation. We're going to set it equal to 0. We'll cross our fingers that it factors. So we're going to go ahead and subtract 25 from both sides of the equation. So we have 2x squared minus 2x minus 24 is equal to 0. We have a greatest common factor of 2, so we're going to divide everything by 2, which is going to make either the quadratic formula or factoring easier. So we divide everything by 2. Alright, so we have x squared minus x minus 12 is equal to 0. And we're looking at a product of two numbers, that is negative 12, that adds up to negative 1. And that would be x minus 4 and x plus 3. And that's going to be equal to 0. Now we would solve each factor equal to 0. X minus 4 is equal to 0. That's going to give us x equals 4. And then we're going to go ahead and substitute that into one of the equations. Doesn't matter which one. Probably one's a little bit easier. So we're going to substitute it into the top equation. Y equals negative 4 plus 1. So that tells us y is equal to negative 3, and that gives us the ordered pair of 4 and negative 3 as our solution. Now x plus 3 is equal to 0, so we're going to subtract 3 from both sides, and that gives us x equals negative 3 is our root. Plug that into the y equals negative x plus 1, so y is equal to negative 3 plus 1, so that'd be 3 plus 1, which is 4, so y is equal to 4. And so that gives us the second solution of negative 3 and 4. And of course, you'll want to substitute this into both equations to make sure that both your answers work out okay. So if we plug into the first equation, we'll do the 4 and the negative 3. So is negative 3 equal to negative 4 plus 1? Yes, it is. So that's good. And negative 3 squared, I'm sorry, that would be 4 squared. 4 squared plus negative 3 squared, is that equal to 25? Well, that's going to be 16 plus 9. That's equal to 25. Okay, so the first solution works. Let's go ahead and check the other one. And does 4 equal negative 3 plus 1? Well, that's exactly what we did right there, so yes, that's good. Okay. And then negative 3 squared plus 4 squared, is that equal to 25? 9 plus 16 is equal to 25. So that checks out. So both our solutions are good. Now let's go ahead and graph this and see what this looks like graphically. Okay. So we're going to go ahead and plot our 2 points on our line. So we have 4 and negative 3. And then our other point is going to be negative 3 and 4. So we're going to go ahead and form the line there. And then we'll go ahead and label that as y equals negative x plus 1. Now we have a circle of radius 5 centered at the origin. So we're going to go ahead and graph that as well. And we'll try to do our best to graph it, and so that looks pretty good. And then you see that we actually, oops, I didn't want to do the eraser, we have our 2 points of intersection. So similar to lines, however, lines will intersect one time, no time, or infinitely many times. A line in a circle they can intersect at two places, at one place, and no place. But I think for the examples we'll be looking at, it'll be intersecting two places. Okay? All right, I got one more of these for you. And, of course, we'll label our circle. All right, so let's look at what we got for the next one. So I have x squared plus y squared is equal to 25. So we're going to look at the circle again. And then we're going to have y equals x squared minus 5. And that's going to be a parabola shifted down 5 units. We can also solve this one by the substitution method. So x squared plus and y squared, we're going to replace the y with x squared minus 5, quantity squared, and that's equal to 25. So you have x squared plus, let's go ahead and FOIL out the x squared minus 5 squared. So that's going to be x squared minus 5 times x squared minus 5. So it's going to be x to the fourth minus 5x squared minus 5x squared and plus 25. So we'll go ahead and combine our like terms. X to the fourth minus 10x squared plus 25. So we have x to the fourth minus 10x squared plus 25 is equal to 25. This is a higher order polynomial, and I pressed the wrong thing. We went a little too far. Okay, so this is a higher order polynomial. Let's go ahead and set it equal to 0 and see what we can do with it. So we're going to go ahead and subtract 25 from both sides. And so we have x to the fourth minus 9x squared, and that's equal to 0. So this is the easiest type of factoring. We're just going to factor out the greatest common factor of an x squared. And what we have left is x squared minus 9, and that's equal to 0. X squared minus 9 is the difference of squares, which factors into x minus 3 and x plus 3. And that's going to be equal to 0. Let's go ahead and erase all this stuff. And we're going to go ahead and plug in our x solutions into, let's use the parabola y equals x squared minus 5. That's going to be easier to work with. Okay, so x is equal to 0. That's going to give us y equals 0 squared minus 5, which is minus 5. So it gives us the first intersection at 0 and negative 5. And then x is equal to 3. That gives us y equals 3 squared minus 5. So that's going to be 9 minus 5, which is 4. So that gives us the ordered pair 3, 4. And then finally x is equal to negative 3. That's going to be y equals negative 3 squared minus 5. So that's going to be 9 minus 5, which is 4 again. So it gives us the ordered pair negative 3 and 4. Now we should check to make sure that these work out in our equations here. So 0 and negative 5. So does 0 squared plus negative 5 squared equal 25? Yes, negative 5 squared is 25, so that works out. And then does negative 5 equals 0 squared minus 5? That's correct. So the first point works in both equations. Okay. All right, now let's take a look at 3 and 4. So 3 squared plus 4 squared, that is equal to 25. We saw that on the last slide. That's 9 plus 16 is 25, so that's good. Okay. All right, now y equals x squared minus 5. So does 4 equal 3 squared minus 5? And that's true. So those two solutions work. Let's go ahead and check the last one, the negative 3 and the negative 4. So negative 3 and 4. All right. So negative 3 squared plus 4 squared, that's certainly equal to 25. 9 plus 16 is 25. So that's good. All right. And then does 4 equal negative 3 squared minus 5? That's true. That's 4 equals 9 minus 5. So all of those solutions work out. All right, and let's go ahead and graph those. So first thing we're going to do is we're going to graph the parabola. And we actually have 3 points there. We got 0 and negative 5. And then we have the point 3 and 4. And we have the point negative 3 and 4. And so there is our parabola of y equals x squared minus 5. And then we have the same circle of radius 5 centered at the origin. So we'll just go out to 5, negative 5, 5, and negative 5. Okay, and there we have it. And then we'll go ahead and label this x squared plus y squared is equal to 25. And what we did is we found where the parabola and the circle intersect. Okay, well, that's it for this video. We'll see you next time.